So good morning, everyone. I hope you are all of you had a coffee and are fit. Let's talk about GraphQL. So has anybody here used GraphQL before? Just a few, that's good. I have a small introduction. So what is GraphQL actually? GraphQL was developed by Facebook in order to make their mobile data fetching more efficient. So it was originally developed to fetch data for their mobile applications that were greatly failing back in the days. In 2015, Facebook decided to open source GraphQL as a specification document, and it was since heavily adopted by the community and companies like Twitter, Netflix, GitHub, and even the New York Times, and many, many more. So what is GraphQL? It is a query language for your APIs and a runtime to execute the queries. I'm Michael Stipe, and I'm one of the co-founders of Chili Cream. And Chili Cream is heavily invested in making GraphQL better on the .NET platform. So who is this talk for? This talk is for everyone who wants to get started with GraphQL. And for people who used it, it's also interesting because we go in more advanced topics like schema stitching. So because I don't like a lot of slides, let's start with a demo. I have prepared a little exercise to get you all into GraphQL. What I want to do is, I hope you all know Star Wars, hopefully. So I want to fetch all the characters that appeared in movies together with Luke Skywalker. That's an easy enough task to do. It's just a list of names. So there is an API that's called the Star Wars API, and this is an exemplary REST API that is frequently used to teach people how to create clean REST APIs. So let's have a look at the swappy.co here. So our REST API exposes a few resources here, like people, planets, films, and many, many more things. And for us developers in the .NET space, it's very easy to explore those APIs, since we all know REST. REST is what drives the web at the moment. So we have here a people's endpoint, and we know how to fetch it. We could do a GET request on that, and we would get some data. And as we expect, we would get a list of characters in this example, like the Luke Skywalker character, or maybe 3CPO, and all the other characters from the Star Wars universe. And it's easy enough to imagine if we put an ID behind the people's endpoint that we would get a specific character object here, like Luke Skywalker. So let's have a closer look at this JSON object here. We all are familiar with JSON objects. They're easy to read and easy to explore. So we have like a lot of attributes here, like the name attribute, Luke Skywalker, and some other attributes. But for our task, we need to fetch all the movies. So here's a films array exposing URIs. And each of these URIs are references to another resource on my REST endpoint. I could follow this along, and then I would get the films object, which is on another endpoint. And again, easy to read, JSON. We have a lot of attributes here, and I get a characters array with all the characters that played in that movie. So I wrote a little program. This is the best I can do for websites. And it fetches all the characters that appeared along Luke Skywalker in the movie with GraphQL and REST. Let's have a look at the REST version. So it's easy enough to infer an algorithm from the data I just showed you. In my little program, I would fetch the Luke Skywalker object. I would iterate over the movies, fetch each of the movies, and then iterate over the characters that appear in each movie, which is here. and then fetch each of those characters. And we can see that this is already not very efficient because we have to do a lot of requests. But let's have a look how that performs actually. Just let me open up the network tab here. Okay, so here we have the network tab of Chrome, and I fire up the REST request. And we can see there are a lot of connections coming in, because as we go deeper in our data graph, we have to fetch more and more data. And that is not very efficient. We need 4.3 seconds to fetch all the names of the characters. And it's just a list of names. And we had to fetch all those data that we actually do not need. Like, we have to fetch Luke Skywalker, and we have to fetch all the data of the movies, and we have to fetch all the data of the resulting characters, although we just need the names. Okay, so let's have a look how we would do such a thing with GraphQL. Let me switch over here. Okay. So there is a program that is called Playground. It's based on GraphiQL, and it's used to explore GraphQL APIs. So I have prepared a little Star Wars GraphQL API. It's basically the same like the REST version, and we are using as a data source actually the REST version in the backend. There is a tabs docs in Playground, and this can be used to explore the GraphQL API. So I can see that there are two fields here. One is called character, and if I click on it, I can see the character returns an object character that has a lot of attributes. And I can see these are the attributes that actually were also in the REST API. And then I can look at the movies field, and I can see instead of returning URIs, movies actually returns movie objects. And the movie object, again, exposes a lot of metadata, and I can drill in further and get, again, characters. So before I have even done my first request against this GraphQL API, I can already explore the structure and shape of my data. Okay, let's see how we can query against this. So we want to do a query, basically read some data on that endpoint. Writing a query is indicated by this keyword query here in GraphQL. And then we can start typing. And because we have all those metadata about the types, Playground can help me along here by providing IntelliSense. So I can pick this character field here, and I already get hinted that there is argument ID here. So I pass in the 1 because I saw that Luke Skywalker has the ID 1 in my REST data, and I can dig in deeper and grab more data. Like let's fetch the name. Let me prettify that. Just let's fetch the name. And I just get the name. And if you look at request and response, it closely aligns. And that is by design. I, as the consumer of the API, can define what data I want, and my endpoint will fulfill my data and send me that back. And if you look at that, you can think of it as a empty JSON graph that you send to the server, and the server fills it up. It's not like that, and GraphQL has much more complex syntax in order to fetch more complex data. But it's a good way to think of it when you want to get started with GraphQL. Okay, let's get back to our task at hand. We wanted to fetch the movies, and actually we wanted from the movies just the characters. We don't want to have the movies, actually. And from the characters that played along with Luke Skywalker, we want the name. So let's get rid of this here. So that's actually what we want. Let's fire that up, and we immediately get the data back that we want. Let's see how that compares in our little unscientific benchmark. So let's get rid here. Fire that up. And it's 300 milliseconds, a bit more. And if we actually look at the requests here, it's 2 requests. And the request that took the time actually was not the GraphQL request, but the course request. So this is the options request from the browser asking if it's allowed to send this request to the server. The actual GraphQL request that fetched the data only took 97 milliseconds. And that's like 40 times faster than the REST APIs. And that's because the backend is more efficient into fetching the data from the relations because we have a much higher bandwidth at the backend. And GraphQL is all about efficiency. So we don't want to send over data that the user doesn't need and use up your data plan on your mobile phone, maybe. Okay, let's get back to our presentation. And let's reflect a bit on the first demo. So in GraphQL, query and response closely align. So you ask the server what you want, and the server will deliver just that. That puts the consumer of the API in the driver's seat. With REST, you can also do dynamic endpoints, and there are a lot of APIs that are very dynamic, like this Amazon Shop API. But it doesn't look that clean, and we couldn't infer type information for that. We could expect that associate tag, for instance, might be an int, might be long, might be anything. We don't know. Or operation might be an enum, it might be a text. We don't know that. REST APIs do not expose type information to us. You can put on top something like Swagger, but that's just metadata. In GraphQL, it's ensured by the query engine that the type information are correct. So REST is more like a trial and error approach, where it can go right, but it could also go wrong. So what is GraphQL actually? So in GraphQL, we don't have over or under fetching. Overfetching is where I have to consume data that I don't need, like the Luke Skywalker object. I had to fetch all the data, but I didn't need it. And underfetching is actually every time we had this arrays where we had URIs, these references are basically underfetching because we wanted the data of the reference, and we had to fetch another time to get that data. So underfetching is always when you have not enough data. In GraphQL, you can get everything in one request, and that's crucial. Like when you're building mobile applications, then you don't want to have multiple requests on a bad network. And in GraphQL, we have a real type system, and the query engine is executing on that type system. That means it's not just fake data like with Swagger, where you tell somebody, these are the types, but you can actually send something else back. And that makes GraphQL simple to use, because we have all those toolings that ensure that we can't write requests that are actually wrong. In GraphQL, I just have one endpoint, and that means I don't have to figure out at which endpoint I get my data that I actually need. In GraphQL, there's no concept of versioning. You can easily deprecate your data, and that makes these endpoints much easier to use. And documentation in GraphQL is basically for free, because by just writing your API, you're also producing a lot of type documentation that tools like Playground can use. And GraphQL is real-time, and we see that in a minute. It's not just like REST, where you say, oh, I need this data, let's fetch it. There's also a way where you tell the server, I need this data when it's changed, and the server will send you that back. And that makes GraphQL more predictable. So let's move on and look at what GraphQL is not, because many talks about GraphQL do not tell you what GraphQL is not, or resolve some wrong ideas about GraphQL. So GraphQL is no graph database query language. It actually has nothing to do with databases. The API I showed you, the Star Wars API, actually fetched its data from the swapi.co. So I fetched with my GraphQL request in the backend the swapi.co data and was 40 times faster on my consuming device than fetching it natively from swapi.co. It's not a good solution for binary streams. So if you are on Netflix, you might like GraphQL, but you wouldn't use it to stream your movies over GraphQL. That might be not a good idea. It's not Facebook's version of OData. Sometimes I get approached at conferences and they ask, oh, can I actually throw away all my OData? These are completely different things. And it doesn't replace OData, and OData has a different space that it occupies. It's not bound to a specific data source. You can use it on any data source. You can use it on databases, you can use it on REST APIs, you can use it on files, it doesn't matter. And it's not limited to HTTP. And that's crucial, because Facebook designed GraphQL to be transport agnostic. GraphQL does not concern about the way it is transported. And it's not limited to JavaScript. That means, although GraphQL is actually exploding in the JavaScript world, it was originally designed to serve data for native mobile applications. And you might not want to use GraphQL if you do simple things like health check endpoint, where you just want to fetch a status from your backend. Okay. Let's have a look at the operations in GraphQL. We saw query. Query is a side effect read on your backend. It could be compared to the GET request in REST. And it's crucial because GraphQL resolvers, these are basically all your fields that get the data for GraphQL, they are executed in parallel on the backend. Then there is a write operation that is called mutation in GraphQL. And in REST, you never know. It's put, post, patch. I always struggled. And delete. And then there is real-time communication. So these are called subscriptions in GraphQL, and you don't have anything in REST that would be comparable to it. So let's see how that works. Let's go over here and go to our second demo. I hope you can see all that. Can everybody read that? Okay. So this is a standard ASP.NET Web API. It has nothing in it. The one thing that I put in here is the Hot Chocolate ASP.NET Core package. So what we did earlier was actually a query request on our API. And I show you how easy it is to build a query API with GraphQL. So the first thing we need is a root type called query. So we can just type up a little class here. Let's do a simple hello world to see how that works. We have the string hello, and let's return world. Okay, awesome. So now we have to create the schema. The schema is the source of all truths in GraphQL. We can add that easily to our dependency injection by saying add GraphQL. And we have something called the schema builder to make that really easy, where we say new, add query, and then we just take the query type down there and say create. And that's basically it. We created our first GraphQL schema. In order to execute on that schema, we need a middleware. And we just have to say app, use GraphQL, and everything is set up. So let's fire that up. Huh. Okay, hello world. Let's refresh our tool, look at the schema, and we can see there is already our query type, and it's of type string. We can see that down here. So let's query our endpoint. And awesome, we have some data. Okay, you can see how easily you can get started with GraphQL. It gets more complex on the way, and we'll have a look at that also. So let's have a look at something else. I told you there's real-time. Let's have a look how real-time works. That was. Okay, fire that up. We get another API here. Sorry. Let's go here, Star Wars local. Okay, that's another Star Wars API, and I have changed it a bit to allow mutations. Let's first look how we write data with GraphQL. So have we the schema there. So with mutations, we would write a keyword mutation here. And then we can basically ask our IntelliSense what mutations we have. We can write a review for Star Wars movies here. And I can pick an episode. So basically, I can tell the API for which episode I want to write a review. Then I have a review here. I can pick the commentary. Maybe, yeah, good movie. And I can give it some stars. Let's give it some stars, 5 stars. Can we clear? Oh, sorry. And then I can reselect data. And let me explain that in a minute. Let's switch that over so we can read better. Okay. So in GraphQL, the actual mutation is just the top-level field. That is the mutation, and that is running with a different algorithm that executes the actual mutation field serially. Everything below is already reselecting data from the changed server state. Like if you have more complex mutations, you can now directly with the mutation, you can reselect the changed data from the server. Okay, let's do that. Okay, this is easy because we wrote it and we get the same back. Not very interesting. Okay, let's head over here and make it more interesting. The next thing is real-time data, so subscription. Let's write a little subscription. So we say, every time there's a new review on my system, I want to fetch that new review. So, and actually, I just want to fetch it if it's written for New Hope, because all the other episodes I'm not interested. And again, I can, like with the queries, I can define what data I want from this review. Maybe I have some aggregation software here, a little backend that aggregates some statistics. So I tell my API, always tell me where the stars that were given to the New Hope episode here. So I can fire that up, and I don't get anything. So usually I get a request down here, but this time I just get this little donut that is going around there. And if I do something here, like writing new reviews, nothing happens here, because I said here I want only the stars on New Hope. So if I now change that and fire that again, I get new results here. And the results would come in as I change data on my backend. And that makes it very powerful. And that actually is how the like buttons in Facebook work. When you push like, a different user might already see that you liked one in real time. And also that is, if you're using Twitter, Twitter is using also GraphQL, and that's how the counts actually go up, like the retweets. When you see them going up, it's done through subscriptions. Okay, so let's move on, because there is a lot of demos I have, and not enough time. Okay, the server is shutting down. Okay, there's another aspect I want to show you before we go into schema stitching, and it's called filters and paging. Because a lot of time, GraphQL is actually used with databases. And there is a company called Prisma in the JavaScript world that did some really cool things to filter on databases with GraphQL. And we actually ported something of that into .NET. And let me show you how that works. So I hope my server died. Yes, it did. Okay. Let's head into my Visual Studio Code here. And I have a little API that actually is some kind of a Twitter API. Let's say it's Twitter. Watch run, because we change it. It's coming up. And let's explore it a little bit. Let's kill that. Stop. Die. Okay. We have it here. So. Okay. So we have fetched the schema, and we can explore the API. Basically, I have a stream of messages here on which I can read. And unfortunately, I get all the data. I don't want all the data because this is a Twitter API, and if it were Twitter, we would be dead because we just loaded all the messages there. And there is a concept in GraphQL that is called paging. But it's not the usual kind of paging you know with two ints. It's called, just a second. Let's go to our query type where we have the messages. It's called cursor-based paging. And it was defined by Facebook in order to slice their data in a more easy way, in a more powerful way, I would say. So in Hot Chocolate, we can just go to our field that exposes all the messages and say we want paging. And let's get rid of that. And we want paging based on this type. And our server should recompile. Yeah, it does. And by doing that, I actually changed my shape of the data. So here's no text anymore. And I get new attributes. So I can say now, get me the first 10. And that's the usual way we page until today. But I also have new types here, like edges. And the edges now give me a cursor and a node. And the node is the actual message now, where I have the text. Let's do that. And instead of having now a skip and take to skip through my data, I have cursors. And these cursors are absolute positions in my data set with sorting. And they are safe against, like, when you insert or change data, they will not reorder your data set. So they guarantee you a kind of order. And this allows me to say, skip to, or give me the next two items after this cursor. And then I get the next two. And it also allows me to say, give me the first two items before this one, or give me the last two items. The last two items. So I can really slice. I can also combine it, like give me the middle of my data set. And it's actually safe against those jumps. That's actually how Facebook does its timeline. So when you scroll through, there are no jumps, like where one story suddenly goes up in your data set. Okay. So, and I set filtering. So this is the paging stuff. Let's get rid of that and change it further. So now we want also to filter on our data, like maybe we just want certain messages. So let's add some filtering. Okay, and just like that, we added a lot of filtering to our API. And I can refetch that. Should be done. And now I not only have the filter stuff, I can say, like, the paging stuff, I can say, give me the first two. where my text is bar. But that wouldn't be interesting. That's an absolute equals. Let's say where my text contains f. I don't know. Do we have something? Yeah. There should be something in with f. Yeah, there's an f in. And I can now do very complex filters. And these filters are rewritten. I can show you that in a minute. I can do now ands, ors, and stuff like that. So you can write very complex filter graphs here. And they are not done in memory. We are actually taking your incoming query request and rewriting it to the specific database. And that makes powerful filtering on your API possible without you writing very special code for it. Okay. That's it for filtering. I'm sorry that we have to jump through that so fast, but otherwise we can't make it. And it's very important that these uses here indicate that these are middlewares. So you can extend that by adding another custom middleware on each field. Like you could actually say, okay, I write my own middleware here and do some more data slicing on top of the transformations. Okay. Okay. How can we do microservices with that? Because I now told you we have one endpoint. And this one endpoint is used to query all that data. That sounds very monolithic. And it kind of is. Because it's good to have one data graph for your whole company. But that would be very difficult to maintain and not very efficient for you. So there's something called schema stitching. And I will show you now what schema stitching is. So the definition basically is the capability to merge multiple schemas. But what does it mean? So with Hot Chocolate, and Hot Chocolate is the only GraphQL server on the .NET platform that can do that. There are others like on the Node platform, there's Apollo. They call it nowadays schema federations. They deprecated their schema stitching, and their new schema stitching is called federation. And then there are platforms like Hasura. They are doing it with Haskell. We are doing it with .NET. Okay. In schema stitching, I can divide my data into multiple microservices. And they could be something like, you could have an Apollo server written in Node. The only important thing here is that it's a GraphQL server. And you could add another server, maybe different data source, and another microservice, like in .NET you use the Hot Chocolate server, or you can have some arbitrary REST. You could have a Swagger endpoint there. Doesn't matter. And the Hot Chocolate gateway will merge all those schemas and make it possible that you can write one query against the gateway, and we divide it up and send the actual request to all those endpoints in the back end with a large bandwidth, collect all of this, and merge it back together and send it back to you. So you have all the benefits of GraphQL without being tied to a monolith. Let's have a look at the code, how we would build up such a schema and how it works. So let's head over to stitching. And I have to, sorry, this is a small one. I have to fire up multiple servers now, so we have a good example. And this example is based on a real project for a company called Swiss Life, which is one of the largest financial companies in the world. They are, I think, the third biggest real estate company in the world that is using actually schema stitching with us. So we go and have a contract schema. I explain it once I started it. Let's run it. CD customer service. Okay, take this, .NET run, they are up. Okay, so let's explore the data. And then I explain what it actually is about. So we have a customer service, and the customer service has all the knowledge about the customer itself. It has like the customer's address, the customer's name, and it also has the consultant that actually sells insurance policies to that customer. So I could explore all the customers here and say, give me the ID and give me the name. And because I can, give me the consultant and its name. And I get the data here. And I could call other functions on this query, like, let's see, I could get a specific customer in order to get his data. Okay, then I have another endpoint. Let me just close these. These don't save, so we have some more space. I could have a contract service here. And the contract service is all about the contracts that the customer has with our company. And if I explore this endpoint, I have a field that is called contracts, and to which I can feed in the customer ID in this case. And then I would get back an ID. It's not very enticing. Okay, and that the company actually exposes different kinds of contracts. And in order to get the data of these contracts, I could use something like an inline fragment and say, okay, if that contract is actually life insurance, give me the premium of that life insurance. And if that contract is some other contract, I kept it simple, give me the expiry date or something like that. And I can fetch the data. So when you talk to your UI guys, they will tell you, oh, now I have, again, 2 endpoints from which I have to fetch my data, and I have to do multiple requests, and it's not cool. And they would tell you maybe that, okay, we are building a customer portal. What we actually want to do is, when the user logs into our application, we know this user is our customer. So what we actually want to do is something like, I want a me endpoint, or a me, it's not an endpoint, a me field. And on that me field, I want to have all the customer data. And then I don't want to ask for the contracts of this customer. I want the customer to have these contracts. So I want actually to say contracts. I don't want to deal with any of those cryptic IDs. I just want to fetch. And that is where schema stitching actually comes in. So let's have a look at the code. Head over here. Yeah, okay. Okay, this is a standard ASP.NET Core application again. The only difference here is that we have set up an HTTP factory, and this HTTP factory knows how to fetch data from these 2 endpoints. And then we have something, when we built our first GraphQL server today, we declared something called a schema. And we have to do that again. Like we would do it like with a normal GraphQL server, we are declaring a schema, but in this case it's a merged schema or a rewritten schema. And we have some helpers for that with add stitch schema extension here. And because we like builders, we have a builder, a stitching builder here. Let's add some squiggles. And then we can say, okay, add a schema from HTTP, and we can grab just one of those client names here, put them in there, repeat that, And then for simple scenarios, we would already be done and have a stitched schema. Let's fire that up. .NET watch run, because we're going to change it. Yeah, should be up. Let's grab a new window, which is on 5000. So we don't have our magic endpoint that we want actually yet, but we have an endpoint that has all the data from both endpoints automatically stitched together. If you look at our query type, we have consultant, contracts, all the fields that the original two services exposed. And we could do something like this. We could grab our first query, put it in here, take our second query, put it in here, and fire it up, and it executes. So our front-end developers wouldn't be happy with that, and actually I'm not happy with that, so let's change it further. So there is a concept of rewriting those types. We can completely rewrite them and pick apart what we need from the types. So what we want is actually to introduce a new field and merge two fields. Sorry. And that can be done with GraphQL, with the SDL syntax, because we don't want to write actual code for it, because the code should stay in the domain services. So let's extend our query type. Type. Extend query. We want the me field, and the me field should be the customer. And now we have to tell the stitching engine from where to get it. So we can add something that is called a directive, and you can compare it to an attribute in C#. So we annotate something on that field, and we say delegate this field to the schema customer, and use a delegation path. You actually don't need that if you have simple properties. I could just, if it could be automatically mapped, I wouldn't need to specify this path. But in this case, you will see in a minute, we actually need it. So we tell our engine to fetch the data from the customer field, and the customer field actually needs an ID. So we can say the ID should be fetched from the context, from our GraphQL context, and let's call it user ID. We can give it any name. Can we reformat it? Yeah. And with our stitching builder, we now say, okay, add extension file, this file that I just have written, extensions.graphql. And then we have to provide some context. You saw I said grab a user ID from the context. So this would be done by, we could inject a request interceptor here. Request, there. Oh, let me paste this in because we are short in time. Oh, actually, I don't have something to paste. Okay. Actually. My cheat sheet. Just a second. There. Reformat it. Okay, what it does here is now, basically we add a property to our context, and it's an ID from the logged in user. Actually, we would grab that from the HTTP context. This is the HTTP context, and maybe look in the user's claims, or fetch it from the database. But for this demo's sake, we'll just add it here, and hope the server recompiles. It recompiles. And now I actually have a me endpoint. I should have, like I wanted. Let's see again. Yes, it's there. And I have the customer that is currently logged in. but I still don't have the execution error. Sorry, that was not good. Okay, that's it with live demos. They sometimes go wrong, but don't worry. I am gonna paste it in. Where's my? Ah, yes, I know, because in my actual demo I had the field named differently. Let's get rid of this. Okay, let's try it again. We fetch it, fire it up, and we get our customer in the me field. And we are still not there because we actually want to merge two types. We want to have the contracts in here. So I can paste in another extension here and tell the customer type to add a field contract that is delegated again to the this time to the contract schema, and this time instead of fetching the data from the context, we are grabbing one of the fields of the type to which we attach this field and feed it in as customer ID here. Save it. Refresh it. And now we have actually what the UI guys want. They can explore this API in a much more cleaner way. They can really dive in from their currently logged in customer, can go into their data and fetch them like they want. But we could do more. I said we could do REST. And we actually could do REST. We could do anything. Because the stitching API allows you to add any code to it to write some kind of adapters. And this again I will copy in because we only have 2 minutes or so. So I could write extensions on my types, or I could even write general adapters. Like this one, where I say, okay, there's some other contract type, I want to extend it, and I want to add a field to it that is called expires in days, which is a non-null int type, and which actually depends on another field, in this case the expiry date, and I want to do some computation here. And then I could just again use my builder, add a schema configuration here, and do some more complex stuff with it. Okay, it's not well formatted, but it should work. Yeah. And then finally, I would also have some computations in. So on my sum contracts type, I not only have the date that I had before in my original data, but I now also have this nice little computation that tells me when my contract expired. This contract actually expired a long time ago. And it's very powerful to get your all your domain services into one endpoint that is very nice queryable in a very human-readable way. Because if you look at these graphs, they are very easy to navigate and explore. Okay, let's get back to our slides. So give you an outlook on our project. We are completely open source, so everything is in the open, everything is under the MIT license. You can contribute, you can fork it, do whatever you want. And you can find us at hotchocolate.io and on GitHub. And all the demos that I showed you are on the GitHub repository .NET Fest. So there are the slides. There are all the demos that I showed you, but in a working state. So you just can grab them and run them. And if you want some stickers, we have stickers. Just approach me. So any questions?
Thank you for the talk. I have a question. How these GraphQL endpoints are actually usually implemented? What about some adapters to the database?
Yeah.
What approaches? Is it better use relational database or document storage? How are there some options to integrate my endpoint to DB?
It actually doesn't matter. You can bring us any data source that you want. Like you could bring an SQL server and we would be fine with it. There is, for those relational stuff, you have something called data loaders that optimize the fetching between database and the GraphQL endpoint. And it's plug and play, basically. You can give us an entity framework context and we just infer your schema from that. So you provide the entity framework and then we will walk your type graph and make it a GraphQL graph.
Okay, thank you.
I have a question about keep data fit on for client. When you show to us that some property on servers are always changing, and like client can subscribe on this changing. So what I have to do on my .NET server side to get client know and be able to subscribe on changings of properties. Thank you.
Yeah, there is. We are actually at the moment working on the client side to make it much easier with .NET to consume GraphQL. At the moment, you could take like a standard HTTP client and fetch the data raw, but it's not nice because you have all these typings and you want the strong types. So in January, we are releasing an API that's called Strawberry Shake, basically the brother to hot chocolate. And this will make it completely easy to consume those endpoints. And you just have to say, okay, this is my API, then we generate you all the types. We do it the same way than the Proto-RP from gRPC. So you can just tell it, this is my GraphQL endpoint, this is my query, and we generate you everything for it.
Thank you for the talk. I have a question about filtering.
Yeah.
The way you are doing it, is it specific for hot chocolate, or is it like standard for, and you can do it on other platforms, on other servers like you?
Yeah, actually there are a lot of platforms that are implementing it now. There's Hasura. I don't know if anybody knows Hasura. They're the Haskell implementation for GraphQL, and they're sitting on top of Postgres. So they are using an approach like this filtering, and Prisma is using an approach like that. So it is not standard, but a lot of them implement it, and we followed their examples. So if you're using Prisma, you should be compatible to us.
Thank you.
Thank you for your speech. You were talking about data adapters to entity framework, which can generate the API according to the database schema, as far as I understood. What tools do you provide for security in order to limit data to those entities which belongs to particular user? You also mentioned Hasura, which is implemented in Haskell. There is also Prisma implemented in Scala.
No, Prisma is in JavaScript.
The server side is implemented in Scala on JVM. And there is also a similar tool called PostgreSQL, which has backend in Node.js and TypeScript. All of them provide a kind of limiting access for authenticated users and automatic database schema introspection. What do you provide from security and database schema introspection?
Yeah, we also provide a lot for that. We have, there is an authorized directive, and we integrate closely with the authorization policies of Microsoft. So you can write policies, and then we enforce them on your fields. And it's very easy. There's a lot of documentation on our site for that, but it's too short to show that in a talk, so I left it out. There's a lot more. There's also sorting. You can write middlewares. You can even write custom middlewares that enforce that. And there's more coming. In January, we are providing something that is the first time that a GraphQL server does it. That's called query execution plans. And we are not doing them like Apollo just on top. We are really putting them in the query engine, and that makes all this data fetching much more efficient. So there's a lot coming, but I think we can do everything that Prisma can do. So there's no difference.
Okay, and we have time for the last question.
A question regarding cursors. So you said that they are persistent. So so where do you store them? In some persistent storage, or do you project them from a primary queue? How are they generated?
They are not persistent in the way that we are saving them. What they mean is they're ensuring that your data stream doesn't jump. There's a problem when you stream data, page data, and somebody else is adding new data to your data set. Then you might not consistently page through your data set if you use a take-skip approach. But with cursors, you actually describe the data set and where you are in that data set. But that is not persistent. It's just the way you are navigating the data that changes.
Okay, let's thank Michael for this interesting topic.